Hello guys, welcome to another question. This is the question number 3, Q using two stacks. Have a quick look at the question and we'll be discussing the approach. Before that, please don't forget to subscribe our channel. If you have any extra email IDs, please do subscribe with all those. That will be very helpful for our channel growth. If you have any doubts, don't forget to comment down and let's go into the approach part. Coming to the approach, the foremost understanding should be what is the meaning of the question first. So let's dwell into the meaning of the question and then we'll be discussing how to approach in terms of coding. Okay, in terms of basic understanding, the question is saying we have to use two stacks and the output should be in the queue format. How is it possible? Let's check by taking one example. Let's assume 1, 2, 3 as element and we are pushing the element from left to right. So 1, 2, 3 has been pushed. Okay, if we use queue data structure, directly queue, the output should be 1, 2, 3. That is using the pop operation. If you use pop operation, okay, then output will be again 1, 2, 3. This is the output of queue. Remember, this is the output of queue, and we cannot pop from the left side because the question is saying us to use the stack data structure. In stack data structure, we have to pop from the right side. Okay. So how can we do that? Is we have to use the same data and we have to reverse it. That will be 3, 2, 1. Now if we use stack data structure here, okay, not queue, stack data structure. After removing, if we use stack data structure, then 1 will be popped, then 2 will be popped, then 3 will be popped. Okay, and if you see and compare 1 2 3 1 2 3 are the same outputs. Okay, you have to always compare it with the starting input. Okay, starting input is 1 2 3, but we have reversed it. Okay, we have reversed it and then we applied stack operation. After reversing, if we apply stack operation, that will act as queue, and it is also true for queue also. Similarly, if you reverse the queue data structure and then pop it, then we get the stack output. Okay, now we are getting the queue output using stack data structure. So this is a basic understanding here what is happening inside the input. Okay, now let's go into the step by step part. Okay, step by step in terms of coding. In terms of coding, we have to take two stacks. Okay, now let's take two stacks and discuss the example. Okay, now let's take two stacks and name one stack as S1. Okay, this will be our S1 and this will be our S2 stack. This is S1, this is S2. Let's take one by one. Okay, there are three conditions. I will be writing down here. I will be writing down here. There are three conditions. Now let's take a step-by-step approach here. Okay, one by one we'll be taking the input. We'll be taking the same example, starting with 1. Okay, now 1 is coming. Now we have to push it. Okay, now we have to push it to S1 and S2. How will we do that is we have to check these three conditions. Okay, if we have to check if any element is present inside the S1. If present, then we pop to S2 data structure. Okay, if it is not present, then we simply append to the stack 1. Okay, this is stack 1 we have appended because there was no data, no mean though there was no data at the start, so we are appending directly using the rule number 2. Now coming to the rule number 3, now we have to check next is if any data present inside the S2 or not. Okay, there is no data present, then we don't have to do anything. But if it is present, then we have to pop it back to S1. Okay, now coming to the second element. Now we're pushing 2 here. Now again check the rules. 2 element has come in the push operation. Now we have to check the first rule. S1 is present. If any element is present inside S1, then we'll pop it to S2. Okay. After popping, this will become 1 here. Okay. And the earlier one will disappear because we have already popped it. Okay, that's the first condition. Okay, first condition has been satisfied. And coming to the second condition, after popping to S2, now we have to append the current element to S1. Okay, now we have appended. Now 2 is inside the S1, 1 is inside S2. Now the third condition, now we have to check S2. Now we have to check S2 if there is any data present inside the S2 or not. Yes, there is data present inside the S2. If it is present, then we pop it. Okay, pop to S1 here. So this will go to here. Okay, that will be the third step, which is the final step here. After popping, we get 1 here. Now if you carefully observe here, okay, we started with 1 2. Okay, at the final output, what we have is 2 and 1. What is 2 and 1 is reverse of the input. Okay, we are implementing this actually. We are implementing this the earlier part that we have discussed, reversing the input list. Okay, that's exactly what we're doing. We're reversing the input list. Okay, if you still isn't clear, let's take one more element. And after that, I hope your all doubts will be clear here. Okay, now take the three element here. Okay, now we have to push it. Okay, now three element here. Now we have to check inside the S1 as a first rule, there are any elements present or not. Okay, now elements are present, then we simply pop these elements to the S2. Okay, now if we pop the elements in S1, the last element is popped according to the stack data structure. So 1 will come here and 2 will come here, and the left side S1 will become empty. So now let's remove those elements because we have already popped and the rule 1 has been satisfied. Now the third input, which is 3, the data 3 input will be appended to S1 because rule 1 has been satisfied. Now rule 2, we're appending the current element, which is 3 here. Okay, now 3 has come. Now again implementing the rule 3. Now rule 3 says whatever elements are there inside the S2, we have to push it back to the S1 using pop. Okay, we have to use pop here. Pop will always pop the last element according to the stack data set. So last element is here is 2 inside S2. So 2 will be popped first, then 1 will be popped first, and the elements in S2 will become 0 now. So this is the final answer here. Okay, so this is the final answer that we have got, and this is used in push operation. Here this is a push operation here, and now we have reversed it. Okay, now this is the 1 2 3 is the input, but 3 2 1 is the output now. From 3 to 1 the data starts. Okay, in after push operation has been completed, we have reversed the input. After reversing, we just simply have to pop the operation. Now using the pop operation here. Okay, pop operation on S1. Okay, where we stored all the elements inside the S1 here. Okay, you can store in S1 or you can store in S2 also. Okay, we can check in a reverse order. We can replace here S2 and here S2 and here S1. Okay, you can just replace S1 and S2. Then all the elements will be stored in S2. Okay, both are same here. We're just using two different stacks here. Either S1 you can use as a final stack or you can use S2 as a final stack. In our case, we have used S1 as the final stack. Now the 3, 2, 1 have been our elements inside the S1. Now if you use a pop operation, and pop operation will be according to the stack data structure. Okay, this is a separate pop here. Pop function you can see in the coding section later. Okay, now using this pop function, if you pop these elements now, okay, if you use pop element, then we get 1 2 3 here. Okay, according to stack data structure, the last element will be removed always. After 1 has been removed, then 2, then 3 will be followed. So this will be your final output. Okay, I hope all the doubts has been cleared. If it isn't still clear, let's check the coding section. Now we are inside the coding section part here, and we have discussed that we have to reverse the input and use a pop operation on that particular stack. Okay, in this example, we are using stack 1 as the final stack and we are popping the elements inside that stack. Okay, basically in push operation, what we are doing is we are reversing the whole input. Okay, whatever the input is given to us in the format of push, we are reversing that input and pushing it into the S stack S1 only. Okay, as a final stack. After making the final stack, we're using that same stack as a pop operation here. You can run this code and check yourself what is happening. Okay, and I hope all of you have understood after seeing the code and my explanation in the presentation. Now you still have doubts, leave a comment below. Okay, and also please don't forget to like our video if you have understood the question, and also don't forget to subscribe. If you have any extra email IDs, please do subscribe our channel, and thank you for watching till the end. Let's meet in another question.